For the beginning of part activity 3.3, I'm actually going to use a program called GeoGebra to do our plotting. So the first thing we have to do is plot x squared plus cosine of x. And so that graph would look like this for k equals 1. You can see the 1 in there. And then it asked us to do it for k equals 3, 5, and 10. So let me add those, and you can kind of see what's going on. So there's with k equals 3, with k equals 5, and with k equals 10. It gets quite a bit more busy. So then it just asked us to do it for k equals 3. Well, what I'm going to do is compare for when k equals 1 versus other values. So this slider is going to allow me to adjust the values of k. So right now k equals 1. And now what we'll do is we'll increase that up to 3. So there's with k equals 3. Notice you can see inflection points because we see a change in concavity, right? Concave up, concave down, concave up, concave down, so on and so forth. And as I go higher, that only increases. So we can get an idea of what happens as k gets larger. You can see the function changing right there. So let's go back to 1. There are no inflection points here. If we go up to 2, we clearly see a change in concavity. Concave up to concave down, back to concave up. So somewhere between 1 and 2, we get inflection points. So let's go back a little bit and see if we can figure out where that happens. Right there does not appear to be any. Still does not appear to be any inflection points. Now it looks like we might have gotten an inflection point, and let's zoom in a little bit there. And it looks like we do have a change in concavity. So it looks like somewhere between 1.4 and 1.5 for a value of k, we start to get inflection points. And we're going to look at that algebraically in part B.